Hello everyone, this is vSphere Kubernetes driver operator project which we open sourced recently, which falls under VMware Tanzu organization. We have open sourced this project, and this project basically provides you the set of CRDs and controllers which helps to deploy, configure and manage the life cycle of CSI and CPI drivers. So for this, it provides you an automated way of managing the life cycle of these drivers. And recently we have released very first version of our project, which is v0.10.beta. And as a part of this release, we provide the functionalities of deploying the video, and also configuring the compatibility metrics, which helps you to manage the dependencies between CSI, CPI and vSphere Kubernetes driver. We also provide you the way to configure and install the vSphere drivers for CSI and CPI. We also provide functionalities for upgrading the CSI and CPI drivers compatibility metrics. And one of the most important features what we provide is the video CTL, which helps you to do all of these functionalities via command line tool. As a part of this release, we provide the deliverables for the video CTL binary for Linux and Macs, as well as we give you a Docker image and a compatibility metrics. So to start with, we need to we need to go to the asset sections and download the video CTL binary. If you are on a Mac, you can download the Mac one, or otherwise the video CTL v0.1.0 beta.tar.gz. So right now I'm in Mac, so let's download this video CTL Mac binary. Once it's downloaded, you can go to the terminal, untar that binary, and basically copy the video CTL binary in your any of the system paths. So right now I have my system path is set to for go bin, so I have just copied it. So once you move it to the path, you can just type in the command video CTL minus help. This will give you the list of commands which are available with the video CTL. By using all of these commands, you will be able to manage the life cycle of the CSI and CPI drivers, as well as the life cycle of video itself. So you will be able to configure the drivers as well as the matrix. You will be able to deploy the video CTL from video from here itself, as well as once the video is deployed, you will be able to see the status of the video, whether it has been deployed and whether the CSI and CPI drivers has been deployed or not. You can also use an update command to update the CSI and CPI drivers via compatibility metrics. And you can also use the version command to see what version of CSI and CPI drivers have been installed. So once we are there, we can first start with the deploy command. So the first thing is we need to deploy the video in our Kubernetes environment. So we can use the video CTL deploy -n spec, and then you can use the video CTL deploy and -n spec and give the spec file. So for getting the spec file, we can go to our GitHub project and go to artifacts directory. Inside the artifacts directory, you can go to vanilla or OpenShift based on your environment. So right now we have a kind cluster, so we'll go to vanilla, and we'll just switch to our tag, the release tag, and then go to the raw contents. So this spec file has the CRDs, all the related CRDs and the service accounts and deployment spec for video. So we can click on the raw and copy the link from there, and now paste the same link over here to start the deployment. So once you hit enter, it will eventually call the Kubernetes APIs and deploy the video over there. So once video is deployed, we can go to the Kubernetes environment and just parallelly check whether video has been deployed or not. So right now we can see it is in the create container configure, because we have still not configured the matrix. So we'll go ahead and configure the matrix. Video CTL configure compatibility metrics, and we need to give the matrix YAML. So we have two options here. Either we can choose the local path or a web URL. So the web web URL, we have, as a part of the release, we have released the compatibility YAML as well. So you can copy the link from here and just paste the YAML. So once you hit enter, we can again parallelly go to the Kubernetes environment and check whether the pods are running or not. So we can see the video controller manager is up and running. So next step will be to provide to configure the drivers. So once you hit the vdoctl configure driver, you will get an option to provide the cloud provider. To configure the cloud provider, this is an optional step. If you don't want to provide configure the cloud provider, you can just skip it, or else you can provide the details of the VCIP and the username, password, and the data center. We have all the checks in the place to validate all of these details, whether the IP and the password and the data centers are correct or not. If in case any of these are these are not valid, it will just give you an option to re-enter the passwords or the IPs. So for this step, let's provide some junk values, some wrong credentials, and see how it works. So here we can see, like, it will give an error saying that the login cannot be completed because of incorrect username and password. So this time let's give correct username and password. So once you give this, you will get an option to configure another cloud provider. If you wish to just go with a single cloud provider, you can just click on no, and then you can also configure the zone and regions of the cloud provider. Then once the cloud provider is configured, you will get an option to configure the storage provider. Again, you give the user credentials for the storage provider. Here, if you have configured the multiple cloud provider, you will get an option to choose the choose which VC you want to configure the storage. So once it's there, you will get an option to configure the file volumes. So once you complete this step, the video has been configured, and eventually the CSI and CPI drivers will be installed in the Kubernetes. We can go to the Kubernetes environment and cross check whether the CSI and CPI has been installed. Right now we can see here that vSphere Cloud Controller Manager has been installed, so CPI has been configured. We'll just check again whether the CSI has been, yes. So we can see here the CSI controller and the CSI node pod also has been configured right now, and all the pods are up and running. Next step is we can get the status of the current deployment. So we can see that cloud provider has been configured with this vCenter IP, and credentials has been verified, and we can see on which all nodes it has been configured. So right now we have a kind environment, so we can see the single node has been configured. We can also see that a storage provider has been deployed on the vCenter IP is there, and the credentials has been verified. We can also check the versions of each of these CSI and CPI drivers which has been deployed. So this will give you an output of what Kubernetes version, what video version, vSphere version, CSI and CPI version, all the related versions can be seen over here. So with this step, we can assume that all our CSI and CPI has been deployed successfully and all things are working fine. Later, if you want to upgrade the CSI version or CPI version, like, you can use the compatibility metrics to do an upgrade. So we have a command called vdoctl update compatibility metrics, by which you can give the link of the new compatibility metrics with the different versions of CSI and CPI, and video will take that version and deploy it. So currently we can see we have another compatibility metrics where the CSI version is 2.2.0 and the current deployed is 2.2.1. So in this case, let's download the CSI version to a more stable one. So let's take this compatibility metrics and provide in the update command. So once you provide that in the update command, video will again intelligently decide which CSI and CPI version needs to be installed, and based on that it will terminate the old pods and bring up the new ones. So here we can see, like, You can see the CSI controller and CSI node has started going to the terminating state. So so ultimately, like all of these old versions of the vSphere CSI controller and the node will go down, and the new versions will come up. We can also check the versions again from the vdoctl version command. So here we can see that CSI version has been downgraded to 2.2.0. So by this we can do the upgrade scenarios for both of these drivers. And you can also we also have a vdoctl delete command, by which we can delete the video itself. By this only the video controller manager pod will be deleted, but the CSI and CPI drivers which has been installed using video will still be there up and running. So if you have any queries related to this project or anything, you can create an issue or raise a PR or connect with us over there in the GitHub. Thank you.